In this video, I'm going to cover finding distance from velocity. So I'm going to just take a step backward to explain the direction I'm going to go. So let's say that I have some graph that has distance over time, and let's say that I'm at home and I travel to work, and then after I get to work, then I'm going to stay for a certain amount of time before I hurry home. Let's say that I go home a little bit quicker. So if we have this distance over time equation, then again, as time continues, you can see that my distance increases, and then it doesn't increase at all when I'm at work. And then you can see that the distance from home decreases until I reach a distance of 0. So in fact, this equation would be a displacement equation. Now, if I calculate the slope, and if you recall, slope is defined by rise over run. And the rise, well, if I'm going up on the graph, the rise is distance in, say, miles. And the run, that's in hours. So, in fact, when we talk about the slope, miles per hour, that's velocity. So that's the same as my velocity. Now, how do you get the velocity? We're getting the velocity by this instantaneous rate of change on the graph. So your velocity is the instantaneous rate of change, or our derivative. So what does it mean then if I'm given a velocity? So let's go back to displacement. So I have a displacement graph, and I take the derivative to get to velocity. So in order to go, if to go from displacement to velocity, I take the derivative. Then to go back, I need to take the integral, or the shaded area. And that's in fact what we're going to be doing today. We're going to be taking the integral. So let's look at this particular problem here. It says the velocity time graph for a train journey is illustrated in the graph alongside. And then it says find the total distance traveled by the train. So this graph represents a velocity equation. So just like on the previous graph that I showed you, to go back to the displacement equation, I need to take the integral, or the shaded area underneath. So I'm going to find out this area right here. And this area right here, it's a triangle. So I'm going to take 1/2. So how about 0.5 times my base, which is 0.1, times the height. This would be what, 30, 40, 50. So that would be 50. And then I'm going to add it to this rectangle here. And that rectangle has just base times height, so base is 0.1 times the height of 50. So that gave me this area here. And now I'm going to find the area for this rectangle here, a base of, again, 0.1 times the height of 50 for this area right here. We're going to do the same thing for this area. I can see that this area here is divided up into one rectangle and one triangle. The rectangle has, so plus a base of 0.1 and a height of 30. And my triangle is a base of, so plus 0.5 times my base, which is 0.1 times my height of, that's from 30 to 50, that's 20. So that gave me, so this, did I find, yeah, that gave me this area here. And then this piece here gave me the area here. Now we have another rectangle here with a base of 0.5 and a height of 30. And then our last, it looks like a triangle, so we have 1/2 times the base times the height. So 1/2, so plus 1/2 times the base of 0.1 times the height of 30. So we just throw all this into our calculator to get what this would give us our distance traveled. So I have 0.5 times 0.1 times 50 plus 0.1 times 50 plus 0.1 times 50 plus 0.1 times 30 plus 0.5 times 0.1 times 20 plus 0.1 times 30 plus 0.5 times 0.1 times 30, and that gives us 21. So we've traveled, how far did the train travel? What was the total distance traveled? It is 21 kilometers. 21 kilometers. So let's look at the next one. It says, a runner has a velocity time graph shown right here, and it says, find the total distance traveled by the runner. So we have a triangle here with a base of 5 and a height of 6. And this is it's a triangle, so we're going to multiply by 1/2 or 0.5. It's just easier to use decimal points because I'm going to throw this into my calculator at the end. Now this next, so that gave me this area right here. Now this next piece here, it's divided up into two pieces. We have a rectangle and a triangle. So we have plus our base here of 5 times our height of 6 plus the rectangle, the triangle here, that's going to be 0.5 or 1/2 times the base times the height. Base times the height. The height is 2, it looks like. That gave us all this area here for both of these pieces here. And then we're going to find, this is a rectangle again, we're going to do a base of, for this rectangle here, a base of 5 and a height of 8. That gave us this area here. And then plus we have a base here of 5. This is a triangle, so 0.5 times our base times our height of 8. And so we could just throw all this into our calculator again to get 0.5 times 5 times 6 plus 5 times 6 plus 0.5 times 5 times 2 plus 5 times 8 plus 0.5 times 5 times 8, and that gives us 100, 110. 100, we're looking at the distance traveled, so the distance traveled is going to be 110 meters. 110 meters. So if we look at number 2, it says a car, so this is a car travels along a straight road with a velocity time function illustrated. It says, what is the significance of the graph above the t-axis? Above the t-axis, that means that the car is traveling forward. The car is traveling forward. Forward. And then for double I, it says below the graph. What does it mean when the graph falls below the x-axis when we're talking about the velocity? Well, the velocity then is going to be, my velocity then is going to be backward. So the car is traveling backward. That's what those mean when we go backward and forward. Now, if we read, if we look, so for part 2, 2b, it says, find the total distance traveled by the car. Well, the total distance traveled by the car is all this area here plus all this area here. So that would be, for this first piece right here, that's going to be, this is a triangle, so we have 0.5, or base times height divided by 2, so we have so we have, this is our half, times our 0.1 times our height of 60, and then plus this, so that would give us this area here, plus this rectangle here, so that would be base times height, so 0.1 times our height of 60, that gave us this area here, and we have another triangle, so plus 0.5 times our base, which is 0.1 times our height of 60. And then we're going to add that to this other area here, which is going to give us, this first one here is a base of 0.1 again, times, we should multiply, this is a triangle, so we need to divide by 2 or multiply by a half or 0.5. I'll just put this out of order, I hope that's okay. And then so we have our base, so 1/2 times our base times our height, it looks like 20, so we're going to multiply by 20 here. And then for this little rectangle here, we have, so plus our base of 0.5 times the height of 20 again. And then this other piece over here, we have plus 0.5 times our base, which is 0.1 times our height of, again, 20. And so we throw all this into our calculator. And so this is going to give us 0.5 plus 0.1, 0.5 times 0.1 times 60 plus 0.1 times 60 plus 0.5 times 0.1 times 60 plus 0.1 times 0.5 times 20 plus 0.1 times 20 plus 0.5 times 0.1 and times 20. So I'm getting 16. So this should be 16 meters, right? We decided that these were, nope, in kilometers. This is kilometers. So we've traveled 16 kilometers. So I'm just remembering back here where we did meters. So this looks like it's in kilometers. So we've traveled 16 kilometers. Now the next one says, so it says find the final displacement of the car from its starting point. So where it started, well, we know that we traveled away here, and then we traveled back here. So that means that we're going to take this, all of the, well, let's make sure. This is this piece here. That is the rectangle, and this is our triangle, minus this other piece right here, and that will give us our total distance. So all I'm going to do then is I'm going to find wherever this actually all this has to be minus, right? Minus, minus, minus. All those are minus. So let's see if I can find it instead of rewriting it all. But the idea is that we're taking this area minus the other area. So I'm going to go back to, I'm trying to find this 0.5 times 0.1 right here. So this is going to be minus. This has to be minus. This one here, we're subtracting this amount as well. And this one here as well. Oh, we have a lot of pieces here. I thought there should have only been 1, 2, 3. There should have only been 3. So I'm just going to go back and look at this. This is 1, 2, 3. I have too many. I have too many that I'm subtracting. So we have this number plus this number plus this other number, and then we subtract the rest. Yeah. We subtract the rest. So we're looking at 8. It should be 8, and we're looking at 8 kilometers. The displacement is 8 kilometers. We traveled a certain distance away, and then we traveled back, and so the total displacement is going to be 8 kilometers. All right, I hope this video is helpful, and have a wonderful day.